Hi, in this video, we are going to continue our discussion of parabolas. So today we'll start off with a few problems that will recap some of the theory that we discussed in the first couple of videos. And after we do those problems, we'll go to more theory, which will be about tangents and normals and chords of a parabola. So let's start with a few questions. The first one is this. Find the equation of the parabola whose axis is parallel to the y-axis and which passes through the points 4, 5, -2, 11 and 4, 21. So basically in this question, we are given 3 points on the parabola and also one information that the axis is parallel to the y-axis. So the axis of parabola is parallel to the y-axis. So you should remember that means the parabola looks like this because this is the axis which is parallel to the y-axis, right? In general, you cannot make a parabola like this. This is wrong because the axis of the parabola would be parallel to the x-axis then. So if the parabola is upward facing, what is the general equation of the parabola? So what we will do is we'll say it is y is equal to ax squared plus bx plus c. This is the general parabola whose axis is parallel to the y-axis, right? So that is the first decision that you have to make. And if you make that correctly, after that, the question is done because you have 3 points on the parabola and you need to know 3 constants, A, B, and C. So now it's just about solving these equations. So we'll say the first equation is we put x is equal to 4, y is 5. So 5 is equal to 16a plus 4b plus c. The second equation would be x is -2 and y is 11. So this will be 11 is equal to 4a minus 2b plus c. And finally, x is 4, y is 21. So this is 16a plus 4b plus c again, right? Actually, this is wrong. X is -4. It cannot be that you have two different points with same x and y. This is -4. So here the equation becomes 16a minus 4b plus c. So now you just have to solve these equations to find out a, b, and c, which you can do easily. You will get a is equal to half, b is equal to -2, and c is equal to 5. And then you get the equation of the parabola as basically x squared by 2 minus 2x plus 5, y is equal to this, right? So this is just simply solving the 3 simultaneous equations to find the 3 unknown constants, right? The key point here is to realize what information is presented to you. If the axis is parallel to the y-axis, your standard equation becomes something like this, right? Let's move on to the next question. This says the points -3, 2 and -3, 1 are the endpoints of the lattice rectum of a parabola. We have to find the equation. Find the equation. Okay. So remember one thing, if the lattice rectum is given like this, you know several things here. The lattice rectum is a chord or a double ordinate that passes through the focus. So if the endpoints are known, the midpoint of that would be the focus of the parabola. Also, the lattice rectum is perpendicular to the axis, right? So that also tells you the equation of the axis and the equation of the directrix. This directrix line is parallel to the latest rectum equation, right? So these are things that we know already for any parabola. So from here, we can easily find the focus. Since these are the endpoints of the latest rectum, focus is midpoint of that. So it will be -3 and 1 plus 2 by 3. So 3 by 2. So focus is known. It is -3 comma 3 by 2. And looking at this 2 points, we can see that equation of latest rectum line is simply x is equal to -3. This is the equation of the latest rectum. So what is a line parallel to this line? Line parallel to x is plus 3 equals 0 is going to be x plus k equals 0, right? This line parallel to the latest rectum will be our directrix. And now we have to find out the value of k, right? So if you think about it, in a standard parabola, y square is equal to 4ax. What was the distance between this line and this line? The directrix and the latest rectum. You should realize that this was x is equal to -a. So this distance was 2a. So 2a is the distance from the equation of the directrix to the equation of the latest rectum. And actually 2a is 1/2 of length of latest rectum. Why? Because this distance, the length of latest rectum was 4a, right? So this distance is half of 4a. That is in a standard parabola. So here, what we know is, since the endpoints of the latest rectum are known, the length of latest rectum is the difference between these 2 points. The distance between these 2 points is 1. So the latest rectum has length 1. So therefore, 1/2 of that, which is half is the distance between these two parallel lines, right? So what we can say now is, from the focus, if you drop a perpendicular to this line, the distance should be equal to half, right? What we are using here is the fact that distance from focus to the directrix is 1/2 of the length of latest rectum. We know the length of latest rectum in this question to be 1. So therefore, the distance from -3 comma 3 by 2 to the line x plus k is 0 must be equal to half. So let's find that now. -3 plus k mod divided by √1 should be equal to 1/2. So we are getting k minus 3 modulus is equal to half. So k could be 5 by 2 or it could be 7 by 2, right? So we have two different options. Therefore, the equation of our directrix can be x plus 5 by 2 equals 0. And it also can be x plus 7 by 2 equals 0. So you'll get two different parabola equations depending on these two different directrices, right? Once we know the directrix, we already know the focus. If you know the focus and the directrix, you can easily find the equation of the parabola by doing PS is equal to PM. But remember, you have two different directrix equations. So you'll get two different parabola equations as the answer, right? So that I will leave to you. You can do that calculation. The next question is this. If a square comma a minus 2 is a point interior to the region of the parabola, y square is equal to 2x, bounded by the chord joining the points 2 comma 2 and 8 comma -4. Then find the set of possible real values of a. Possible real values of a. Okay. So first of all, they are saying this point is in the interior of in a certain region of the parabola. which is bounded by the chord and all, right? So obviously it is inside the parabola. If you remember, we had discussed the theory that this region is known as the interior of the parabola. And how do we find whether a point is in the interior? We take the coordinates of that point, we put it in the parabola equation, and it should come out as negative, right? If it is in the interior. So what we can say here is point a square comma a minus 2 lies inside parabola y square is equal to 2x. And the way that will happen is if we put this in this equation, it should come out as negative. A minus 2 whole square minus 2a square is less than 0, right? So let's simplify this a little bit. This will become a square minus 2a square. So minus a square minus 4a plus 4 is less than 0, which means a square plus 4a minus 4 is greater than 0. And from here, we can complete the square and say a square plus 4 minus 8. So a plus 2 whole square is greater than 8. So we can say that either a plus 2 is greater than 2 root 2 or a plus 2 is less than minus 2 root 2. So a is greater than 2 root 2 minus 2 or a is less than minus 2 root 2 minus 2. Right now, this is what we are getting for a, right? Also, there is some additional information. So if we draw the chord on the parabola, joining these points, one point is 2 comma 2 and one point is 8 comma minus 4. So maybe I should draw the chord appropriately. This is my parabola. One point is 2 comma 2 here. One point is somewhere here, 8 comma minus 4. And let's draw the chord. The question has also said to us that this point is in the interior to the region of the parabola bounded by the chord joining this one. So the point is somewhere here in this region, right? So what we can say is the point P is somewhere here and the chord is given by this. Notice that the vertex of the parabola is 0, 0, right? So you can say one thing from here that the vertex of the parabola and point P are on the same side of the line on the same side of the chord, right? Of chord. That is another piece of information that we know. Any straight line divides the plane into two halves. This is one side and this is one side. You can see that both the origin and the point P lie on the same side of the line. So what we will do first here is write the equation of this line, and you can find the equation of this line by doing 2-point form. You can see the equation will come out to be x plus y equals 4. That is the equation of this line. You can check it yourself. Now, both the origin, the vertex of the parabola, and the point lie on the same side of the line. How do we check whether they lie on the same side? We can put the origin in that line equation. You will get 0 plus 0 minus 4 or negative, right? So when you put origin in the line equation, you get negative value. So now we should also realize that if the P is on the same side of the line as the origin, if you put the point P's coordinate in this line equation, it should also come negative. Both will have the same sign. Now we have another relation from here. We will say that a square and a minus 2, when you put in this line equation, it will come out to be negative. Let me do it on the next page. You get a square plus a minus 2 whole square. A square plus a minus 2 minus 4 should come out as negative. This is a square plus a minus 6 is less than 0. And from here we get, by simple factorization, a plus 3 and a minus 2 is less than 0, which means minus 3 is less than a is less than 2, right? So this is what we are getting from here. And notice earlier we had gotten a is less than minus 2 root 2. This was the region of a, and there was a region here, it is greater than 2 root 2 minus 2, right? 2 root 2 minus 2. 2 root 2 minus 2 is actually smaller than 2, by the way. And this is minus 3 is bigger than this. So our region was, from the earlier condition, it was this region. And from this condition, we have between minus 3 to 2, right? So the intersection of both would be basically the region from there is no intersection this side because it is above minus 3, but this side it is coming below this, right? So there is no intersection here. The intersection only happens on this side where we are saying it is greater than 2 root 2 minus 2, which is here, and it is less than 2. So the set is 2 root 2 minus 2 to 2. This is the set of values of A that are possible, right? So that becomes our answer here. So hopefully you have understood how we are applying these ideas in problems. Now, what I will do is I'll start talking about some of the theory that we need to study. So the first thing is equation of a chord joining the points x1 comma y1 and x2 comma y2 on parabola y square is equal to 4ax. Right. So first of all, the straight line joining this equation of that is very obvious. It is y minus y1 is equal to y2 minus y1 by x2 minus x1 multiplied by x minus x1. This is the standard equation of a straight line joining two known points. However, since both these points are lying on the parabola, we also have y1 square is equal to 4ax1 and y2 square is equal to 4ax2. So we can simplify this equation a little bit by putting these data here. So we can see y2 minus y1 by x2 minus x1 can be written as, if you multiply this by y1 plus y2 by y1 plus y2, this will become y2 square minus y1 square by x2 minus x1 times y1 plus y2, right? What have I done here? I'm trying to simplify the slope a little bit. To do that, I have multiplied it by this. Why? Because that makes it y2 square minus y1 square. And I know what that is. Y2 square minus y1 square is equal to 4a x2 minus x1, right? So we'll use that here. So this becomes 4a x2 minus x1. And that will cancel the x2 minus x1 present in the denominator. And you'll have y1 plus y2 here. This will get cancelled. And basically the slope is coming out to be 4a by y1 plus y2, right? So what I'm getting now is y minus y1 is equal to 4a by y1 plus y2 multiplied by x minus x1. This becomes the equation of the chord joining two points. Chord joining two points. And notice that the slope of the chord is simply 4a by y1 plus y2, right? So this equation is not something you have to memorize. I'm just showing it to you so that you understand what is happening and how to get the equation of the chord and how we use the condition that the points lie on the parabola, right? Later, when we do parametric form, these equations will become much simpler, okay? So don't worry about it so much, just understand what we are doing. Also, from this chord equation, we can try and derive the tangent equation. Try to find the equation of the tangent from the chord equation. So we have our equation came out as this 4a by y1 plus y2 x minus x1. And this was the equation of the chord joining the 2 points x1 y1 and x2 y2, right? Now, usually this is my chord. These are the 2 points. This is the line that is the chord, right? But if you think about it, this is x2 comma y2 and this is x1 comma y1. If the point comes closer and closer to P, I'm saying bring Q, which is x2, y2, closer and closer to P. then the chord equation starts changing, right? If you are bringing the chord equation, the chord line starts changing. And in the limiting case where x2 tends to x1 and y2 tends to y1, basically you will realize that the chord equation will become, chord line becomes tangent, right? Chord lines becomes the tangent line in the limiting case when x2 tends to x1 and y2 tends to y1, right? So if that happens, you can realize here that the slope here would become y2 tends to y1. So it becomes 4a by 2y1 and x minus x1 and y minus y1, right? So you get 2a by y1, x minus x1, y minus y1. And if you multiply it a little bit, you'll get y1 minus y1 square is equal to 2ax minus 2ax1. This is the equation of the chord so far. So let's see what that means. We can say y1 is equal to 2ax plus y1 square minus 2ax1. But y1 square is a point on the parabola, so y1 square is 4ax1. So y1 is equal to 2ax plus 4ax1 minus 2ax1 is 2ax1 plus, right? You're getting y1 is equal to 2ax plus x1. This is what is becoming our equation of the tangent. So what we have gotten is y1 is equal to 2ax plus x1. And this becomes equation of tangent to the parabola, to parabola y square is equal to 4ax at the point x1 comma y1. Obviously, the way we got it here was converting a chord equation, converting a chord equation to the tangent equation, to tangent equation. And we did that by actually bringing the point x2 comma y2 and saying that it tends towards x1 comma y1 and seeing how the chord equation got changed, right? So that is one way to get this equation. Obviously, there are other ways to find the tangent equation. One way would be to use calculus. So if this is my curve, the slope of the curve, you will get 2y dy by dx is equal to 4a. So dy by dx is equal to 2a by y. And this basically becomes the slope of tangent to the parabola. So if you need the slope of tangent at a particular point, for example, if I need it at the point x1 comma y1, we know that the m at the tangent, m of the tangent at that point will become 2a by y1. So the equation of the tangent will be y minus y1 is equal to 2a by y1 x minus x1, which as you recall was the same equation we got in the previous case as well, right? If you simplify this, you will get y1 is equal to 2a x plus x1. Right? This is going to become your equation of the tangent to the parabola at the point x1 comma y1. Notice one thing here, for any general conic ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals 0. For any general conic, even if it is not a parabola, even if it's a circle or a hyperbola or an ellipse and so on, equation of tangent to this curve at x1 comma y1 point can be found by replacing, by doing this process. What we do is we replace in this curve equation x square with x1, y square with y1, x square with x1, y square with y1, 2xy with x1y plus xy1, 2x with x plus x1, 2y with y plus y1, and we keep c same as c. So this process, if you apply, you will always get the correct equation of tangent at x1, y1. So notice that we could have gotten, if you have y square is equal to 4ax is the equation of the parabola, Doing this process, you would get y square is replaced by y1 and 4ax. So 4a times x is replaced by x plus x1 by 2. So you will get 2a times x plus x1. So that is the same equation of tangent that we got by the other methods earlier. So one method was take the equation of the chord and bring the 2 points of the chord close to each other. The second method was the calculus method, finding derivative and finding the slope and finding the equation of the tangent line from there. The third method is the standard replacement method. If you know the point at which you need to find the equation of the tangent, all you need to do is replace these things in the curve equation and you will get the tangent equation directly. So this is a very important method that everyone should know because it gives us the tangent equation in one step. The derivation for this can be done through calculus, and later at a later stage, we might even show you the derivation. Right now, you don't need to worry about it. Now, the fourth different form of the tangent equation, this is very important, and this is a slightly different form of the tangent equation. We want to find the tangent equation in terms of the slope of that line, slope of that tangent. So we are going to find the condition that the line y is equal to mx plus c is tangent to the parabola, is tangent to y square is equal to 4ax, right? So there are two ways to do this. One way gives you the point of tangency and the other way gives you the condition easily. So let's do it the first way. Let x1, y1 be the point where line y is equal to mx plus c touches the parabola y square is equal to 4ax, right? So equation of tangent at x1, y1 to this parabola, we already know is y1 is equal to 2ax plus x1. We have already seen that, right? And since the tangent equation is also y is equal to mx plus c, both these lines mean the same thing. Both these equations coincide. And if these equations coincide, we can compare the coefficients and say y1 by 1 is equal to 2a by m is equal to 2a x1 by c. And from here, we can see that x1 is equal to c by m and y1 is equal to 2a by m, right? Also, we know that x1, y1 lies on parabola. Y square is equal to 4ax. So we know that y1 square is equal to 4ax1, right? So from y1 square is equal to 4ax1, we can say y1 square will become 4a square by m square is equal to 4ax1. So c by m. So from here, 4a gets cancelled and m gets cancelled and we get the condition c is equal to a by m. So if c is equal to a by m, the point of tangent c becomes x1 is equal to a by m square and y1 becomes 2a by m. So what we are getting is the condition that the line is tangent to the parabola. The condition is c is equal to a by m and the point of tangency is a by m square comma 2a by m. This is the point where the line y is equal to mx plus c will touch the parabola. How did we do this? We took the equation of the tangent to the parabola at random point x1, y1. That was y1 is equal to 2ax plus x1. And we took the line equation. These two must represent the same tangent line. So we compared the coefficients. From there, we got x1 is equal to c by m and y1 is equal to 2a by m. And from the fact that x1, y1 lies on the parabola, we know y1 square is 4a x1. And using these two results together, we get c is equal to a by m. And we also get the point of tangency a by m square and 2a by m, right? So remember the point of tangency of this line, if it is tangent to the parabola, it is a by m square comma 2a by m, right? That is something that is important to know. The next method is a simpler method. If you have y is equal to mx plus c, which is tangent to y square is equal to 4ax, we can say that let's try to solve this line equation with the parabola equation. Usually when you solve a line equation with a 2-degree curve, the line could cut the curve at 2 points. This is y is equal to mx plus c. This line is a chord of the parabola. So it cuts the curve at 2 points. And if you try to solve the equation here, you should get 2 real roots. And that condition would be discriminant greater than 0. However, if it touches the parabola, we have 2 equal roots. And that condition would be d is equal to 0, right? So what we will say is we'll try to solve these two equations. For that, we'll say mx plus c whole square is equal to 4ax. This becomes m square x square plus 2mc minus 4a times x plus c square. This is my quadratic on x. And the discriminant must be equal to 0 for this to be a tangent. Because if it is tangent, it is touching the parabola and both the roots must be equal. So this discriminant is equal to 0, which means you have 4 times mc minus 2a whole square minus 4m square c square is equal to 0. So you get mc minus 2a whole square is equal to m square c square. So this becomes minus 4mca plus 4a square is equal to 0, which means a square is equal to amc. So a is equal to mc or c is equal to a by m. Right? So we get the same condition of tangency, and notice that the equation of the tangent now looks like y is equal to mx plus a by m. So y is equal to mx plus a by m is the tangent to the parabola. Y square is equal to 4ax. And we also know the point of tangency. It is a by m square, a by m square comma 2a by m. That is the point of tangency. Right? Okay. Now, another idea that you need to know is that from any point external to the parabola, two tangents can be drawn to it. Two tangents can be drawn to the parabola. So basically, if my equation of the parabola is this, y square is equal to 4ax, from a point P, h, comma k, I can actually draw two tangents to this parabola. One tangent here, one tangent here, right? And the way to do that is to say that if I have this tangent equation was y is equal to mx plus a by m, because we know the parabola equation is this, the tangent equation will be this, and let's say that this tangent passes through point P, which is h comma k. You will be able to put the point in this tangent line equation. You will get k is equal to mh plus a by m. And notice that this is a quadratic in n. You get something like this. So m square h minus mk plus a is equal to 0. So since this is a quadratic in m, and if you check the discriminant here, it is k square minus 4ah. Now notice that this is the discriminant of the quadratic, and since the point PHK lies outside the parabola, we know that this quadratic is this value k square minus 4ah is greater than 0. We have discussed this before. If the point is outside the parabola, if you put that point in the parabola equation, the value comes out to be positive. So since this discriminant is greater than 0, this equation has two real and unequal roots. Two real and unequal roots. And these two roots stand for two different values of the slope. Notice that both these lines have two different slopes. No? So we get two different tangents with different slopes. What we can say is both of them pass through h comma k, and the relation between the slopes is coming out to be m1 plus m2 is equal to k by h, and the product of the slopes m1 m2 is equal to a by h, right? So you can find these slopes also, and you can find the two different equations as well. But what we know basically is that from an external point, you can draw two tangents to the parabola, right? That is the main idea here. Okay. Let's now go over to the theory of normal. And what is a normal? A normal to any curve is a line that is perpendicular to the tangent at the point of tangency, right? So if S is equal to 0 is the equation of the parabola, and P is a point on the parabola, then the line through P and perpendicular to the tangent at P, tangent to S at P, is the normal to the parabola at P. So that is the basic meaning of a normal. So how do we find normal equation? So there are multiple ways to do that. So if you have y square is equal to 4ax is my parabola equation, and I want the normal with slope m. What is the equation of the normal with slope m to this parabola, right? So if I differentiate this, I get dy by dx is equal to 2y dy by dx is 4a. So I get dy by dx is equal to 2a by y. This actually is the slope of the tangent, right? So at point P, which is x1 comma y1, the slope of the tangent is equal to 2a by y1. Therefore, slope of normal would be minus y1 by 2a because it is perpendicular to the tangent. So if I call the slope of normal here as m, I will say m is equal to minus y1 by 2a. And from here, I get y1 is equal to minus 2am, right? This is an information that we have figured out from here, that y1 is equal to minus 2am. And here m is known as the slope of the normal, right? Now, because we have y1, x1, y1 lies on the parabola, we have y1 square is equal to 4a x1, and y1 square will be 4a square m square. So 4a square m square is equal to 4a x1. So we are getting x1 is equal to am square, right? So the point is x1 comma y1 is am square comma minus 2am, right? So now the equation of the normal, it passes through the point x1, y1, and that point is becoming am square comma minus 2am, and it has slope of m. Slope of normal is m. So the equation of normal will be y minus 2am. So y plus 2am is equal to m times x minus am square. So this becomes y is equal to mx minus am cube minus 2am. This is the equation of the normal with a given slope. This is one form of the normal equation. The other form is the standard form. You have point x1 comma y1. The equation of the tangent was y minus y1 is equal to 2a by y1 x minus x1. This was tangent. So obviously equation of normal will be y minus y1 is equal to minus y1 by 2a x minus x1. This is the standard normal equation, right? So these are pretty basic things. Now we will discuss a particular theory that is sometimes asked in problems. So I will just discuss this theory right away. So we have to find the number of normals to a parabola that can be drawn through a single point, that can be drawn through a given point. So what is the meaning of this statement? So given any point inside the parabola or outside, how many normals can you draw from here? So for example, this line might be normal, this line might be normal, and again, another line somewhere might be normal, although it doesn't look like a normal here. So basically, through a given point P, how many normals to the parabola can be drawn, right, from that point? So that is what we need to understand. So think about it. The equation of normal to y square is equal to 4ax at the point 8t square comma 280. So this is the parametric form of a point on the parabola. Remember, we have not yet discussed parametric form, that will come in the next class. So don't worry about that too much. The equation of the normal will come out to be tx plus y is equal to 280 plus 80 cubed. I will discuss this equation and the derivation in the next class. However, you might be already familiar with this. So this is my normal equation to the parabola at this parametric point. And if this line passes through point P, which is h comma k, let's say, or let's call it x1 comma y1, then we have t x1 plus y1 is equal to 2at plus at cubed, because the normal is passing through x1 y1, right? So this equation is a cubic in t. You can see that you can write this equation as at cubed plus 2a minus x1 times t minus y1 is equal to 0. This is a cubic in t, and basically the number of normals that pass through x1 y1 would be the number of real roots of this cubic. Number of real roots of this cubic. So the real roots of this cubic could be 1 or 3. Any cubic equation will have 1 or 3 real roots. That is a concept from the theory of equations. And later we will show what is the condition for the normal, there to be 3 normals or 1 normal, right? So look at this cubic and we have to figure out the condition based on this cubic, how many real roots it has. If it has 1 real root, we have 1 normal. And if it has 3 real roots, we have 3 normals, right? So we will discuss this condition slightly later when we look at some problems based on this. For now, just know that you can have 1 or 3 normals drawn to a point, through a point, to a parabola, right? Okay, then we have one more theory here, which is the equation of the chord of contact. So first of all, what is chord of contact? Chord of contact is basically the line joining the point of tangency of two tangents. So let's say these are two tangents to a parabola drawn from an external point h comma k. From h comma k, you have drawn two tangents. This is point Q, this is point R. The equation of the chord QR. This chord QR is known as chord of contact, because it is the line that connects the points of contact of two different tangents to the parabola, right? Now, if the standard equation of the parabola is y square is equal to 4ax, the equation of chord of contact comes out to be exactly same as the tangent equation, as if the tangent was made from h comma k. So we'll say yk is equal to 2ax plus h. You follow the same process as if you are drawing the tangent to the curve at point h comma k. Then you would have written equation of the tangent would be this. Obviously, that is not true because h comma k is outside the parabola and you cannot draw a tangent from at a point which is not even on the curve, right? But the equation looks like the equation of tangent to the parabola at h comma k. The proof of this is very clever and very smart. Like, you will basically say that let's call this point x1 comma y1 and let's call this point x2 comma y2. Find the equation of the tangent to the parabola at x1 y1 and the equation at x2 y2 and say that h comma k lies on both the tangents. From these two equations, we can see that we get two different relations involving h comma k, and that tells us the line equation of this QR. So I would recommend that you go through the SL section on parabola to see the proof here. And if you don't understand the proof, I will discuss it in more detail. It is not so difficult, but it's a very clever way to do the proof, finding this line equation. It avoids any calculations. It's very smart. So you should go through the SL section on parabola about chord of contact to understand this better, right? And let me know if you don't understand it. I will explain it to you. So that's about it for this video. What we will do in the next class is a lot of problems on tangents and normals. And also we'll cover the parametric form of the parabola. Parametric equations in the parabola, basically for tangents, normals, and everything. So next class we'll also have some problems and some theory. And please stay tuned for that. Hopefully you are learning something from these videos. Make sure that you follow each video carefully. The theory that we are discussing is absolutely important for JEE. So make notes, try and understand every concept, and you will be fine with conic sections by the time we finish this course. So that's all for now. See you next time.